All right, let's get into it. We live on a planet that feels pretty solid, right? But deep down, way beneath our feet, there are these incredible forces just constantly at work, shaping and reshaping the very ground we stand on. So today, we're going to explore that powerful engine inside our planet.
See, our planet can be incredibly patient, but it can also be pretty violently abrupt. I mean, it can spend millions of years pushing up a mountain range, just bit by bit. Or it can unleash all its power in an instant and carve out a massive crater, just like this one, in what's really a geological blink of an eye.
And that contrast, between the super slow and the super sudden, it brings up a really fascinating question. What is this one source of power that can do both? How can this immense internal engine operate on such completely different schedules?
Well, to find the answer, we have to look deep inside the Earth. All of this geologic drama, it's not coming from the sun or the atmosphere. Nope, it's coming from the planet's own superheated core and mantle. The scientific term for this whole thing is endogenic processes. Endo literally means within, and genic means originating from. So we're simply talking about processes that are powered by energy that comes from inside the Earth. And this is the master force behind building all the big stuff in our world.
So where does all this internal energy come from? Well, it's not just one thing. A huge chunk of it is from the decay of radioactive elements deep within the planet. Another piece comes from friction, just the friction from the Earth's rotation and the gravitational pull of the moon. And then there's the leftover heat, the primordial heat, from when our planet was first forming billions of years ago. Okay, so this internal energy doesn't just bubble up randomly. It actually shows up on the surface in two very distinct ways, and it operates at two totally different speeds. And getting these two categories is really the key to understanding how our continents and mountains are formed. Now, this diagram might look a little complex, but it's a great blueprint for us. For right now, just look at that top split. See how endogenic forces branches out into two main types? On the left, you've got diastrophic forces, those are the slow builders, and on the right, sudden forces. We're going to walk through both of these.
So here's the crucial point, this big division. We have the diastrophic forces, the slow and steady builders that work over these immense timescales. And then you've got the sudden forces, the fast and furious shapers that can change a whole landscape literally overnight.
Let's dive into that first category, diastrophism. These are the powerful, persistent forces that are responsible for the grand architecture of our planet. We're talking the continents and the huge mountain ranges.
Think of diastrophism as the master architect. It's the sum of all the processes that move, elevate, or build up these enormous chunks of the Earth's crust. And it's so slow that you can only see its effects after thousands or even millions of years.
And this master process, it really gets broken down into two main types of movement. First, you've got orogenic processes, which are all about building mountains. And second, you have epiorogenic processes, which focus on building up or lifting entire continents.
Orogenic processes are what happen when tectonic plates collide. This creates this incredible horizontal compression, and it causes the Earth's crust to buckle, to fold, and to fracture. It's kind of like pushing two rugs together. The material has nowhere to go but up.
And if you want a perfect real-world example of orogenesis, look no further than the Himalayas. Those towering peaks were formed, and hey, they're still being formed, by the collision of the Indian and Eurasian tectonic plates. This is mountain building in action, right now.
Epiorogenic processes, though, are different. Instead of that horizontal crunching, think of a broad, vertical movement. These forces lift or lower huge blocks of land without a lot of that intense folding and faulting. It's a much more gentle, large-scale kind of continental uplift.
A classic case of this is the broad uplift that raised large parts of the American West, including the southern Rocky Mountain region. This wasn't some violent collision, but a slow, massive elevation of an entire region that shaped the continent itself.
All right, let's hop over to the other side of our blueprint and see how this internal energy can be released in a much more dramatic, sudden way. I mean, these are the forces you see on the nightly news.
So first up is volcanism. This is basically a direct pipeline for the Earth's internal heat to make a break for it. It's the movement of molten rock, or magma, from deep inside the mantle up towards the surface where it can erupt as lava.
This diagram gives us a great cross-section of what's happening. Deep below the solid crust, there's this weaker, kind of plastic-like layer called the asthenosphere.
You can see it labeled right there in the mantle. Magma from this layer finds pathways to travel up. When it finally breaks through to the surface, that's what builds the volcanoes and all the landforms we see.
The other sudden force is, of course, an earthquake. So while those diastrophic forces are slowly building up all this stress along fractures in the Earth's crust, we call those faults, an earthquake is the moment all that stress is violently released. The rocks suddenly slip, and that sends shock waves out in every direction. So, when you put it all together, what does it all mean? Well, we have these two competing, but also kind of complementary systems. One that slowly builds the world's biggest features, and another that violently reshapes them in an instant.
And here's the key takeaway. The beautiful, varied landscape of our world, the towering mountains, the deep valleys, the vast continents, it all exists because these internal forces aren't uniform. They're constantly at work, pushing and pulling, building and breaking, and creating this tectonically controlled, uneven surface that we call home.
So the next time you see a mountain range or hear about a volcano, you'll know the story behind it, right? A story written by these patient architects and these sudden demolishers, all powered from deep within. It's just a reminder that the ground beneath our feet is never truly still, which makes you wonder, what's it building next?